In this question, we are required to find the integral of 2x plus 3 divided by 2x squared plus 6x plus 9. So how do we start? The first thing I would look out for is if this integral looks like a known pattern, integral pattern. And if I cannot identify a pattern, the next thing I could try is to see if the denominator, being a polynomial of order 2, can be factored, right? If I can factor it, then I can break this whole expression into partial fractions. And if that happens, then I can break this whole integral into the sum of two simpler integrals. Now, even if I cannot break this into the denominator into partial fractions, or sorry, into factors, then I can still complete the square. And after completing the square, then I can attempt to use trig substitution, trigonometry substitution. The last approach I can try is to use U substitution. Now, the problem with that thought process is that if you're not sure of the step to take or the approach to use, then you might try a method or an approach that will not work, and then that would lead to a waste of time, and then you have to return to trying another method in the hope that it will work, right? Here, we're going to solve this question, and I'll explain why I chose the approach I'm using, and then try to explain how to look for clues or patterns that would give you that will point out the approach for to be used in solving the question. So in this question, I would use U substitution. So to start, I'm going to say let U be equal to the whole denominator, which is 2x squared plus 6x plus 9. The next step is that I'm going to differentiate this and then solve for dx. So now I'll have du dx is equal to differentiate this, the exponent of x will come down, or you bring it down and multiply the coefficient here by that exponent. So we have 2 multiplied by 2, which will give me 4, and then you drop 1 from the power. So x to the power of 2 minus 1, which is x to the power of 1. Likewise, the power here is 1, exponent is 1, so 1 multiplied by 1 is 6, and then drop 1 from 1, so 1 minus 1, you get 0, so x to the power of 0 is 0. Oh, sorry, it's 1 rather. So x to the power of 1 minus 1, which is x to the power of 0, which is 1. So you have 6 times 1, which is still 6. Now the derivative of 9, which is a constant, is 0, so that drops out. Now we'll solve for dx. So we have dx or du. I will cross multiply, then I'll have 4x plus 6 multiplied by dx. I can simply divide all through by 4x plus 6 because I'm trying to solve for dx. So I need to isolate dx on one side of the equation. Now when you do that, this cancels this, so I can simply have my dx is equal to du divided by 4x plus 6. Now, if you look at this, I can further simplify this by factoring 2 out here. 2x plus 3 when I factor 2. Now, this looks familiar, doesn't it? If you look at the original question, we have 2x plus 3 at the top, and then we have it here. When things like this occur, or you notice that the derivative of the denominator or part of the numerator, because it doesn't have to be in this form, will cancel the other parts of the numerator or the then U substitution might work. And let's see. And from the jump, from the get-go, I noticed that if I differentiate this, I'm going to get something like this that will cancel out with the numerator. So I already know that use substitution, where I substitute the whole denominator, is going to simplify my whole question. So let's bring the question down. So we have 2x plus 3 here. Instead of the denominator here, I'm plugging in u. And instead of dx here, dx is equal to this, I'll plug in the u2 into 2x plus 3. Now, this is where the simplification occurs. This cancels this. And as you can see, I have successfully eliminated all terms with x. So I can rewrite this. I can actually bring, okay, let me just not skip a step. So I'm left with this, and I can rewrite it as 1 divided by 2 outside, because it's a constant integral, 1 divided by u du. And this is a known pattern, right? The integral of 1 divided by a variable, where the variable in this case is u, is the natural log of that variable. So this gives me 1 divided by 2 natural log of u plus a constant c. Now, the last thing I need to do is just plug in the value of u, which I used in the substitution initially. Therefore, my integral is 1 divided by 2 natural log of 2x squared plus 6x plus 9 plus c. And that's it. Simple as that. Thank you.